Hi, everyone. I'm Henry Toll, and today I'm going to be talking about named entity recognition, or NER for short. So, what is named entity recognition? So, named entity recognition, commonly referred to as NER, is a process in natural language processing where machines are trained to identify and to classify important information in text, such as names of people, organizations, locations, and dates. Essentially, NER helps machines understand and extract key data from vast amounts of text. NER works by analyzing text and identifying entities, like in this first line example, I live at 123 Main Street, Anytown, USA, which it identifies as an address, and the social security number 123456789, which the model identifies as a social security number. So NER does this by using machine learning models trained on annotated data sets where these entities have been labeled manually. Once trained, the model can automatically recognize and categorize entities in new unseen text and text it has never seen before. So NER models, many of them are something called pre-trained NER models, which provide out-of-the-box availability. Some common ones is spaCy, Stanford NER, and FLAIR, some leading pre-trained NER solutions. These models are designed to recognize entities like names, locations, organizations right out of the box. spaCy is fast and production ready. Stanford NER is highly customizable and research oriented, and FLAIR excels in capturing contextual meaning for more nuanced entity recognition. But while these models are ready out of the box, they are overly general for many domain-specific tasks, rendering them virtually useless in real business applications where high precision is needed. So the problem that a Note AI recognized is that these pre-trained NER models are useful, but there are significant benefits to training your own custom NER models, especially for specialized tasks. So a Note AI provides a no-code solution that allows businesses to train their own NER models on their own customized annotated NER data. This allows businesses to create high-precision NER models for their own domain-specific tasks, allowing them to easily integrate a reliable NER model into their workflow. For example, NAR is essential in healthcare, where there are robust legal protections against leaking sensitive personal identifiable information on patients in accordance with federal law. In this case, a company could train a custom NER model with a note on removing that personal patient information from patient records to store on their online service. The key way to tell that an NER model is doing better is by evaluating it. NER is often evaluated with the ground truth, meaning that you compare it to proven entities that are recognizable and comparing what the model's output is. Here's some key evaluation metrics we use that once your NER model is deployed on our service, you can manually get the information for. Precision measures how accurate the model's predictions are. It calculates the proportion of correctly identified entities out of all entities, the model's prediction. Recall, on the other hand, measures the model's ability to find all relevant entities in the text. It calculates the proportion of correctly identified entities out of all actual identities present, so false negatives. F1 score is a harmonic mean of precision and recall, providing a single metric that balances both, particularly useful when you need to weigh the trade-offs between them. And then we have IOU, or intersection over union, which is a metric that is often used to evaluate the accuracy of bounding boxes in object detection, but can be applied to NER. It measures the overlap between ground truth and prediction spans. So a Note AI provides you an NER model that you can use to pre-train on your custom data. You can customize your own private NER model with a no-code solution using your own annotated data. Then allows you to evaluate your trained NER model against your own data and be your real-world application use case. This means a Note AI provides you the tools to harness the power of AI directly into your stack in an easy and directly applicable manner. So going into the product demo, we go over to our documents and get into our evaluation metrics, where you can see our direct formula that we use in the code for precision, recall, the F1 score, intersection over union. You can also see how this would be an example in the report that you would get on your own data. This table, if you have a sentence with a ground truth entity, you can see the precision recall F1 score and the intercept over union. In development, it would look like this. Yeah. Anyone have any questions on NER? If not, then I think I can pass it along.